Lecture 4, the linear model. In Lecture 1, we looked at probability theory and random variables, and in Lectures 2 and 3, we looked at the fundamentals of statistical inference. And those first 3 lectures of the course provide the foundations necessary to go on and formulate and analyse statistical models. And in this lecture, we're going to talk about perhaps the most fundamental and well-known statistical model, and that is the linear model. So the lecture is divided into 8 parts. As usual, I'm going to begin by outlining the learning outcomes, and I then want to set the context by talking generally about statistical models, about what their aims and objectives are, and we'll look at how the linear model fits into that general setting. In part 3, we'll look at some specific properties of the linear regression models. What do we mean by linear regression? What makes a model linear in this sense? Then in sections 4 and 5 of the lecture, we're going to go on and look at how we estimate a linear regression model. First, by looking at a mathematical solution known as least squares, and then secondly, by looking at the statistical properties of that solution. So the statistical properties of least squares we'll look at also in section 4.6, where we go on to make the assumption that the errors in the linear regression model are normal, and that's going to let us conduct estimation and inference using various techniques that we've talked about in lectures 2 and 3. And then finally, in part 7 of the lecture, we're going to go through an example of linear regression which we will execute in the statistical software R. And then in the last part of the lecture, as usual, I will summarise what we've learned. So, in terms of learning outcomes, at the end of this lecture, you should be able to explain what the linear regression model is and describe its key properties. I want you to be able to implement ordinary least squares, a mathematical algorithm that we're going to use to calculate parameter estimates or estimate parameters. I want you to be able to derive the statistical properties of the least squares solution using the theory of probability and the theory of inference that we covered previously in lectures 1 and 2. I want you to be able to implement methods for diagnostic testing of least squares estimates with normal errors. And finally, I want you to be able to execute least squares estimation of the linear model using the software R, and we'll provide an example of how that works.